Okay, it's 1 o'clock, so let's go ahead and get started today. All right, afternoon, everybody. How's everyone feeling today? It's the class before the midterm.
Good.
Good. Good. Good. Yeah, hopefully dying AF. Yeah, it's definitely that time of the semester. So I know you guys are loaded with midterms, so it maybe doesn't mean much coming from me, but hang in there. It'll pass for sure. Okay, so the plan for today is we're going to continue on with our lecture notes for rate of return. I don't think we're going to finish it today, so I think we'll have a little bit left over for next Tuesday. But that's kind of the plan for today. So our next class period on Thursday is going to be the midterm. And so, just like, a lot of people have been asking about, what are we going to do on Thursday? So Thursday, I'm not going to hold lecture. So there's nothing, it'll be as if, we were taking the exam in the class. So there's going to be no new content, but I'll open up the Zoom call, in case you wanted a place to kind of directly ask me questions, clarifications, or, how to take the exam. So I'll be there for that. But otherwise, it's totally optional. So you don't have to show up for the Zoom call on Thursday. And if you have any questions on the exam, you can either send me an email, or you can, if you're on the Discord, you can direct message me on Discord as well, and I'll be happy to answer you there too. Okay. And so besides that, are there just any questions on, or any more questions about the exam, or just anything we covered last time? So the question is, are there solutions to the midterm review? Oh, you mean the midterm study guide? No, I don't have the solutions for those. I think you're probably asking for the conceptual questions. So all the answers to those can be found in the lecture notes, but I don't have them formally written up in one place. So it's mostly just meant to be just a kind of a guide for your studying, not necessarily problems to do. But if you can go through that study guide and and kind of at least pinpoint in the lecture notes where you can answer those questions, I think that's kind of a good way to use that. Okay. Okay, so there's no more questions. Let's go ahead and get started. Right. And so last time on Thursday, we were doing an example with rate of return. Okay. And so let's kind of pick up right there. Okay. So I think last time, we did kind of a pretty basic example for rate of return just to illustrate what it's like. And so, remember the idea with rate of return, it's kind of a different perspective from the economic problems that we've been doing before. Where always before we were given the interest rate and we're supposed to solve for one of the cash flows, but in rate of return problems, I'm going to give you all the cash flows that you would construct the cash flow diagram for, but instead you're going to be solving for basically the interest rate. Okay, and so this is the example that we were working on. Look like this. And so on this guy, we had a uniform series up front, or we had an initial benefit, right? This goes up to year 3, and all these guys are 9,000. Okay. And then we also had a uniform series going down irregularly over here. And all these were 8,316, okay? And so we're given, basically all the cash flows up front. And if you remember, the way that we set up these rate of return problems is that we'll compute the net present worth of all these cash flows and then set it equal to 0. Okay.
So nothing is happening on year 4, right?
Nothing's happening on year 4. Year 4 is blank. Okay. And so I think that's where we left off last time. So if we computed the present worth for everything here, and so first thing that we had was an initial benefit. And so this $9,000 on year 0, that's going to be 9,000, just like that. Okay. Then we also had the uniform series that goes from years 1 to 3. So it's going to be a plus 9,000. Okay. And then we're going to convert this to a present sum. So this is going to be P over A. We don't know the interest rate. This is going to be for 3 years. Okay. And then to this, we're going to, and then from this, we're going to subtract our 8,316. Okay. So we have minus 8,316. Okay. And since this is a uniform series that starts at a later date, you know, we need to do a couple conversions here. So the first thing we need to do is convert this into a single sum on year 4. Okay. So in order to do that, we're going to do P over A. I, and this goes on for 5 years. Okay. And then from this location here, this is a single sum in year 4, and so we need to transport that back to year 0, and so this can be a P over F I 4. Okay. And so again, you know, this converts to single sum in year 4. And then this part right here, what this is going to do is going to take that single sum in year 4 and take it back to year 0. Okay. And so now that we've set up this expression, we can set this all of this equal to 0. Okay. Right. And then from here, you know, you have a couple different options. So I think last week we covered, you know, one option you can do is you can use the tables for this, which is, you know, the primary method I'm going to show you here. Or if you feel comfortable using the equations, you can plug in the equation expressions for these. And, you know, and a lot of times those equations won't be directly solvable, so you'll have to plot it in some kind of program. But I'll show you the table method, which I think is at least doesn't require any MATLAB, and it's you know, it requires some work, but it's usually not too bad. Okay. All right. Any questions on this? Okay. All right. So let's solve this with the table method. So with the table method, what we're going to do is we're going to start, you know, plugging in values of I. And you don't want to do this randomly. You want to do it with some kind of systematic approach. And so what I'm going to do here is I'm going to start by assuming that the interest rate is 0, and then from there, you know, evaluating at different interest rates. I'll go from 0 to 1 to 2 to 3. Okay, and eventually, you know, your net present worth will hopefully it'll equal 0, because that's what we want. But more than likely, you're not going to get an exact value of 0. And so what you're going to look for is you're going to look for the place where the net present worth changes sign. Okay. Okay. And by changes sign, what I mean is that it goes either from positive to negative or negative to positive. Okay. Because if it changes sign like that, that means that the location where the net present worth is 0 is in between those two. And then what we're going to do from there is interpolate. Okay, so let's start plugging stuff in. So let's start with an interest rate of 0. Okay. And so I equals 0 is a special case, and I actually don't even know if it's that's in your compound interest tables. Let me take a quick check. No, it's not even in the compound interest tables, but for I is equal to 0, you know, these are the usual things that you plug in. Okay, most of the times you're not going to start at 0, but I think, you know, just for completeness, I just kind of want to just show you what it's like. And so if you have an interest rate of 0, you basically assume that the value of money is not going to change with time. So any factor that's P over F or F over P, all these guys are going to equal 1. Okay, and any P over A factor will equal just N. Okay, and so let's start. Let's plug all those things in. And so we're going to compute the present worth with an interest rate of 0. Okay, and then what we get from that is 9,000 And then plus the next thing that we add is our 9,000 multiplied by our P over A factor. And so that's going to be 9,000. In this case, since we have an interest rate of 0, we're just going to plug in n. So our first n for this is going to be 3, okay? Because that uniform series takes place for 3 years. And then from that, we're going to subtract our 8,316. Okay? Or 8,316. And then we're going to multiply by a P over A with n is equal to 5. And so we're going to multiply by 5. And then we're going to multiply by 1 because that's a P over F factor. Okay? And so we plug in all those values and we get minus 5,180. Okay? Right? And so you can see we have a negative present worth. So the interest rate for this problem is not 0. Okay, so now let's compute the present worth for an interest rate of 1. And so with an interest rate of 1, you can look this up in the tables, okay? And these are the values that you get. So for an interest rate of 1%, you get 9,000 plus 9,000 multiplied by 2.941, okay, minus 8,316, okay, multiplied by 4.853, and then multiplied by 0.961. Okay. We add all those together and we get minus 3,314.60. Okay. And so you can see we still have a negative number, but we're getting close to 0. So we're going to continue on doing this. And so next I'm going to do interest rate of 2, and then I'm going to do an interest rate of 3, and then eventually, hopefully we get something positive that we can, we can start to interpolate from there. Okay. All right. Any questions on this example so far? Okay. Okay. So then let's compute the present worth with an interest rate of 2. Okay. And so this is going to be 9,000 plus 9,000 times 2.884. Okay. Then we're going to subtract 8,316 times 4.713 times 0.9238. Okay, what this gets us is minus 1250.78. Okay, so we're getting warmer. Okay. And then finally, let's do present worth of 3. And so, you can, this follows the exact same formula. It's just our conversion factors here in the parentheses are going to be different. Okay. And so you plug all those things in for a present worth of 3, and you get a positive 620.45. Okay. And so you can see right here, once we go from 2% to 3%, the net present worth goes from negative to positive. Okay. And so we found the place where our net present worth changes sign. So what this tells us is that the rate of return for this problem is somewhere between 2% and 3%. And so for these cases, I think someone mentioned it last time that in these cases where your rate of return is between these two values, the way that we're going to solve for the exact rate of return is we're going to interpolate. Okay. And I'll show you the formula that I use to do so on the next page. Okay. All right. Any questions on this? Okay. Okay, so the formula I use to interpolate looks something like this. So we're going to say that IRR, okay, and so, oh, what happened? If IRR, now my thing is thicker. weird. Okay, so IRR is going to be equal to, where IRR here is an acronym. So this stands for internal rate of return. Okay, and so this is going to be equal to I low. This is kind of obnoxious. I low plus I high minus I low, okay, multiplied by 0 minus PW low, all divided by PW high minus PW low. Okay. All right. So let's define all of these variables here. Okay. So I low. This is the lower interest rate. Okay. And so in this particular problem, our lower interest rate is 2, and so we're going to plug in 2 for that. Okay. And then PW low. Okay. You have to be careful with these PW high and PW low, because this is not just the lower present worth or the higher present worth. Okay. PW low right here is the present worth associated with the lower interest rate. Okay. And so that's I low and PW low. Right now we have I high. My stylus will cooperate. Okay. And so I high, similarly, this is going to be the higher interest rate. Okay. And then PW high, this is the present worth that's associated with that higher interest rate. Okay. And so the key word there is associated. So it could be, you could have a situation where you compute the present worth for, like, something at 2%, and the present worth is like, 500 something. But then you compute the present worth at a higher interest rate, like 3%, and then the present worth will drop to negative 500. So you make sure you guys keep these the same. So in this particular problem, these line up, and so the interest rate or the present worth for the lower interest rate is actually lower than the other one. But just make sure you're careful using this formula, that you pick the right or you assign the right present worth for PW low and PW high. Okay. All right. And so on the next page, we're going to fill this guy in. Okay. But are there any questions on this formula here? Okay. Okay. Oh, that's what happened. I zoomed in. It's weird. Okay, and so let's go ahead and plug in for this example. So in this example, we have I low. And so I low in this case was 2%. Okay. And PW low, this was minus 1250.58. Okay. I high in this case was 3%. And PW high was 620.45. Okay. And so we plug that in, we get IRR is equal to I low, which is 2, plus the difference between them. And so the difference between them is going to be 3 minus 2. Okay. And then in the brackets here, we have 0 minus PW low. So PW low, we're going to plug in our minus 1250.58. And then in the denominator, we're going to have P high, which is 620. 0.45 minus a negative 1250.58. Okay. And so you punch these into your calculator, and what you get is an interest rate of 2.67%. Right. And so the rate of return for this problem is 2.67. All right, so question. So in that case of being invested, we still use the lower interest rate, not the associated lower interest rate. In the case being inverse, we still use the lower interest rate, not the associated lower interest rate. That's correct. And so I low and I high, that's always going to be the actual lower interest rate and the actual higher interest rate. It's just the present worths that are associated with them. You know, you have to do that. You have to make sure that these guys are matched right here. Okay. Right.
Professor.
Yep.
For the I low and I high, do we estimate those, or are those given to us?
And so those are ones that you looked up in the table. So in this particular problem, you know, what I did for this was I started from the compound interest tables, and I started plugging in some interest rates, because, you know, before up to this point, we had this expression right here for the present worth, right? But then we don't know I, so we can't fill in any of the terms in parentheses. And so to do these kind of rate of return problems, you kind of have to do a guess and check, where you go to the compound interest tables, and you say, okay, I'm going to start at 0% or 1%. You can start wherever you want, and then from your guessed interest rate, you start filling in these values, and then you find the two interest rates where the present worth changes sign. So it either goes from positive to negative or negative to positive, and then that's how you get your I low and I high.
Okay,
so,
thank you.
Yep. Mm-hmm. Yeah. Once we do a couple more of these, it'll make more sense. And usually for these problems, what I'll give you a starting point, because if you start from 0 every time, but the interest rate ends up being like, you know, 9%, you're going to be doing a lot of guessing and checking. So usually what I'll do is that, you know, I'll say, you know, I'll give you hints, like maybe you should start looking around interest rate 7%. And then from there, you can, you know, start evaluating some present worths either above or below that 7%. Yeah. Okay. Any more questions on this? Okay. And so one thing I do want to highlight for this, and it kind of goes back to Isaac's question a little bit, is that for this particular problem, you know, as we increased our interest rate, the net present worth also increased. Okay. And so in these situations where, you know, the present worth is getting higher and higher at higher interest rates, this is very typical of a loan. And so, you know, at this point, I kind of want to draw the distinction between a loan and an investment. Okay. So for a loan, you know, the way a loan typically works is that you receive money in the present day, or, you know, in the times, you know, leading up to this. And so in this particular problem, you know, we received $9,000 on year 0, and then we received $9,000 each year for the first 3 years. Okay? And so we're getting money now, but then eventually we're going to be paying that money back at a future date. So that's what a loan typically is. Okay? An investment is something that's opposite of that. So an investment, you're going to pay out money today. So you're going to lose access to some money in the present day, but later on, you know, you're going to earn money off of that investment. So and so investments will have a large, usually initial cost, and then that's made up for with you know, future benefits. And loans are typically opposite. Okay. And so what we can do is we can actually plot, you know, the relationship between present worth and interest rate that's typical for a loan and an investment. Okay. And so if we draw a coordinate axis like this, where our x-axis here is given by the interest rate, and our y-axis is the present worth, okay? And let's say that this is for a loan. Okay, so for a loan, it would look something like this. So for really low interest rates, you know, we're going to have a very negative present worth. So it might be something like this. But then as you increase the interest rate, you know, that present worth will climb higher. Okay, and so this is typically what what we saw in the previous example, right? And so when we evaluated the present worth at an interest rate of 0 and 1% and 2%, you know, they were pretty negative numbers. But then after we evaluated at 3%, you know, as we climbed more, the present worth got more and more. Okay? And so the opposite is true for an investment. Okay, so this is for an investment. So an investment would look something like this, where you start high and then you end low like that. Okay. And so these are kind of the, you know, just kind of typical behaviors. So if you're doing a rate of return problem and you see that as you evaluate higher interest rates, your present worth is going up, then that's going to be typical of a loan. But if you see as you compute higher and higher, or you evaluate it at a higher and higher interest rate, your present worth is going down, then that's going to be an investment. Okay. Okay. Let's see. And so the way that you can kind of think of this is that, you know, it's kind of a different way. Oh, so the question is it 1250.78 or 1250? So 58. Yeah. Unless I typo. No, it should be 78. Sorry. Yep. Thank you. Okay. And so the reason for this, at least for the loans, you can kind of think of it like this. Okay. And it's kind of a different way to kind of view these cash flows. So, you know, for a loan, you know, typically, you know, when you take out a loan, you know, let's just say that you take out a loan from your uncle, right? So you say that, you know, your uncle is going to lend you $1,000 today, and then he wants you to pay it back, you know, in a certain amount of payments. So let's say that, you know, he's going to charge you $100 a month for 12 months. Okay? And so, you know, you can easily so you can just using kind of the same methodology that we did, you can compute the interest rate on that loan. Okay. And so if the interest rate was actually lower than that, like say, you know, your uncle had an interest rate in mind, then you're kind of, if that interest rate was lower than the one that you computed, and the one that you computed is kind of this guy right here, where the two graphs where the graph kind of crosses the x-axis. If the interest rate that your uncle had in mind was actually down here, you know, then you kind of got scammed a little bit, because, you know, you're paying your uncle more money than it was actually worth in his head. Okay? But if the interest rate in your uncle's head was up here, right, and say that, you know, I could have made, you know, 5% off of this loan, then you kind of got away with the steal. So you kind of you had a net gain of money, because the computed interest rate was different from what it was before. So it's kind of a strange concept, but, you know, as long as you kind of remember that for loans you're going to go up at higher interest rates, and for investments you're going to go down. That's kind of the most important part of this part right here. Okay. Any questions on this? Okay. All right, so let's talk some more applications. So, you know, that's kind of the basics of rate of returns. And so we did an example where, you know, the numbers worked out really well, and then we just did an example now where we had to interpolate to find that. So, you know, so the question now is, you know, how and why is rate of return used in practice? And so, you know, I'm going to go over kind of a couple typical situations that you might find, you know, either in your personal life or also, you know, in engineering as well, right? And so the first common situation is, you know, say that you want to, you know, purchase a new, something that's relatively expensive. So you can think of like, you know, a nice piece of furniture or like a new machine or like something that you're going to use in engineering. Okay. And so, you know, oftentimes for these kinds of purchases, you know, the vendor or the person selling to you will give you an option of whether to pay it all up front or to pay in installments. Okay. Okay. And so typically what happens is that if you choose to pay it all up front, you know, it's going to be less money overall that you're going to be paying because, you know, because the vendor prefers that so that they have the money now. Okay. And so you can kind of think of it also like of like buying things in bulk at Costco, right? So you buy, you know, a ton of stuff, you're kind of overloading yourself on like you buy 10 pounds of ground beef or something at Costco, right? And so Costco will give you a benefit for you know, buying that 10 pounds of ground beef right now versus buying like a pound of ground beef every week. Okay? Downside is that, you know, you paid for a lot of ground beef and then you're probably going to be making either a lot of burgers or a lot of tacos for the next week or so. Okay. And so let me show you kind of an example of, you know, talking about kind of the how we can use rate of return to kind of quantify these this discount that you get for paying all of them. Okay. And so let's say that you're considering the purchase of a 6,000 electric generator. Okay. And so that's what you're considering purchasing. And then the vendor is giving you the option of whether you can either pay it, you can give him the money right now, or you can or he's going to let you pay it in 12 monthly installments. But the vendor says that, you know, I really need some money right now so I can, you know, use it to run my company. And so if you buy this $6,000 electric generator today, I'll give you a 15% discount. Okay. And so at a 15% discount, we multiply our 6,000 here by 0.85, and then the price of the generator drops to $5,100. Okay. Right. Or the other option, pay $6,000 in 12 monthly payments at no interest rate. Okay. And so this is, you know, a pretty simple example because, you know, you can kind of see right away that if you pay it in monthly installments, you save yourself 900 bucks. And so it kind of seems like it's just a lot of work for nothing to compute the rate of return. But, you know, this is kind of an example of just showing you how you can compute the rate of return. Okay. And so the problem, what we want to solve is we want to compute the monthly rate of return for choosing to pay up front versus the financing. Okay. And so basically what we're going to do is that we're going to compare the two options where if we paid $5,100 today, and then we compare that to doing 12 equal monthly payments of $500. Okay? And so what's the interest rate that we gain by paying this $5,100 upfront? Okay, any questions on this? Okay. Okay, and so the first thing that we need to compute is what are our monthly payments if we choose the financing. Okay. Right, so we're lucky here that it's, you know, there's no interest rate, so we're just going to simply divide. And so what we're going to do is we're going to take our 6,000 divided by the 12 months, and then what that gives us is $500 per month. So it's just, you know, 6,000 divided by 12. Okay. And since this is a an amount that we're going to pay every month, this is a uniform series. Okay. Okay. And so, you know, remember that if we're choosing to pay up front, you know, we're going to be expected to save money relative to the financing plan. And actually, you know, that amount of money is 900 bucks. Okay. And so when we compute the rate of return is basically going to be an expression of how much money that we're going to save each month, you know, relative to the financing plan. Or not how much money, how much we save each month. Okay. Okay. And so what we're going to do is we're going to compute the present worths of both of these options. Okay. And so same thing that we did for before, and then set them equal to each other, and then solve for I. Okay. All right, so let's go ahead and do that. So the present worth of buying it up front is simply just going to be $5,100. And then we're going to set this equal to the present worth of our monthly payment. So our monthly payment is $500. Okay. But since this is a uniform series, we need to convert this to a present sum. That's going to be P over A, I, and then 12 months. Okay. And so if we divide both sides by 500, and what we get is, and so we're going to put this all onto one side and then set it equal to 0. Okay. And so what we have is present worth is equal to 5,100 minus 500, P over A, I 12, and then we're going to set this equal to 0. Okay. And then we're going to do the same method that we did in the past example, where we're just going to start plugging in values of I, and then find the place where this guy changes sign. Okay. Okay. Any questions on this? Okay. Okay, so let's start plugging in. So, you know, in the last problem we started from 0, but in this problem, since you know, I kind of already know the answer, let's start from a place where it's convenient. So let's start at an interest rate of 2.5. Okay. And so if we evaluate this at 2.5, what we get is 5,100 minus 500 multiplied by 10.258. Okay. Then what we get is minus 29. Okay. And so now let's evaluate this at 3%. Okay. And so at 3%, we're going to have 5,100 minus 500 multiplied by 9.954. Okay. And this is going to be equal to 123. Okay. And so you see that this between 2.5 and 3, we went from negative to positive, and so this is where our sign changed. Okay. And so let's interpolate between these guys in order to compute the rate of return. Okay. And so, okay, so we have IRR, and this is equal to 2.5. Because remember, 2.5 is our lower interest rate here. Okay, and to this we're going to add 3 minus 2.5 times 0 minus PW low. So in this case, PW low is minus 29. Okay. And then we're going to do PW high, which is 123, minus negative 29. Okay, and so if we plug in all those numbers into a calculator, what we get is 2.595%. Okay. And so the way that we're going to interpret this result is to say that, you know, if we paid it all up front, so we paid the $1,500, $5,100, and then this is basically equivalent to having a monthly interest rate of 2.595%. Okay. And so that's how much money that we would gain, or that's kind of an expression of how much we would gain each month if we paid up front versus, you know, doing it in installments. Okay. Right. And so, the way to think of it is like you pay up front, you pay $5,100, and then for the next 12 months, you don't have to pay $500 each month. And so that difference in that payment each month is it results in an interest rate of 2.595%. Okay. All right. Any questions on this example?
Question. Sorry, how would it change if you like were to invest, because like instead of paying all the money up front, like you invest that money in like a bank at like 3%, and then obviously you'd be making some money each of the month instead of paying it all up front.
Mm-hmm.
Like
yeah, actually that's a good way to kind of think of it too. So like Jonathan was saying, you know, one way that you can kind of look at this too is that you would take it's kind of like you took that $5,100 and then you would gain basically like $500 per month, and this is like the interest rate that you would gain on it. But if you were able to, you know, invest this money into a bank at 3%, then you would be making more money than that, because the interest rate would be higher than what we computed for our rate of return. So that's definitely another great way to think about this too. And actually, you know, that's going to form the basis of, you know, what we're going to do later on, which is, you know, how do we use rate of return to actually choose between different alternatives? Because a lot of times, you know, the best thing, instead of, you know, buying a fleet of new trucks, the best thing would maybe just be to take your money and just invest it in a bank, because you would get a higher rate of return on that than if you bought some machinery. So rate of return will basically give us a way to kind of evaluate that.
Okay, great, thank you.
Mm-hmm. Was there another?
Yeah, it's me. Can you scroll up where you have 600 divided by 12 is equal to 500?
Oh yeah.
I kind of missed a part of how'd you get that.
Yeah. So so in this case, it's a special case because we have a uniform series payment, but it's interest free. So interest free basically means that we can just take whatever the principal amount for the loan in this case, which is $6,000, and you just divide it by the number of periods. And so in this case, we were paying it off in 12 equal payments. And so we just take 6,000 and then we divide it by 12, which is a number. And then that's how much we pay each month, basically.
Oh, I wrote 600. Oh, sorry.
Oh, okay.
All right, then thank you.
Yep. Mm-hmm. All right. Any other questions on this?
So 2.595% means that you're getting is that monthly?
Yeah, that's monthly. So actually, yeah, actually, I think Jonathan's and I had never thought about the way that Jonathan kind of said too, is that this is basically the same thing as if you paid $5,100 for like an investment, and then you would get $500 each month, and then if you did that, then you would get an interest rate of 2.595% each month. Yeah.
Thank you.
Mm-hmm. Yeah. And so a situation that occurs like this in practice, so not only for engineering companies, but for any company that you work for, is that oftentimes in at least for American companies, you also get kind of like health insurance, dental, vision with your job. And so the way that companies provide this is that they usually strike a deal with the insurance companies, and insurance companies usually give them an option. So they can either say that you can buy an insurance plan for your whole company, and you can pay it all up front, or you can do it in installments. So obviously if you pay it up front, then you're going to save some money in the long run. But sometimes that's not an option, because say that you want to buy this generator, but you don't have $5,100 on you right now. So just to make sure that you have enough money to take care of your employees or other immediate expenses, sometimes you kind of have to do the financing plan or the installment plan, just to make sure you have more money on hand. Right? Okay, and so let's do another example, which is another common situation in engineering. Is oftentimes when you want to buy or use equipment for a project, you're often faced with the dilemma of whether to buy the equipment or lease it. Okay. Okay, and so let's do an example for this. Okay. And so let's say that an engineering company has a project in mind where they need to purchase they need to use some additional equipment. Okay. And so the company can buy this equipment. And so if they buy the equipment, it's going to cost $40,000. And the nice thing about buying the equipment is that then they have sole ownership, and then at the end of 24 months they can salvage it for $6,000. For 24 months. Okay. In 24 months, we'll say that that's the life of the project. Okay. And so the other option is that we can the company can lease it for $2,500 a month. Okay. And so we're going to compute the IRR for purchasing the equipment to see which one is kind of the better option. Okay, and so before we do that, let's summarize all the cash flows in this problem in a table. Okay. Okay, and so we're going to break this down. So the first thing we're going to do is we're going to have something at month 0. Okay, so that's the initial day cost. Okay. And then we're going to summarize the costs for years or for months 1 through 23. And then we're going to have the cost for month 24. Okay. And so if we buy, okay, it's going to cost us $40,000 today. Okay. And so we're going to assume that the machine doesn't need any maintenance or it's negligible, right? So we're going to say from months 1 through 23, we're going to have zero cost there. Okay. And then in month 24, you know, since we own the equipment, we can sell it or we can salvage it for $6,000 bucks. Okay. Okay. And then we can summarize all the payments for leasing as well. Okay. And so for leasing, you know, so when you typically lease something, they want the payments at the beginning of the month because they're not going to let you use their machine for a month and then say, or you can use it for 29 days and say, okay, I'm done. So, and then you don't pay anything, right? But so usually there's if you want to lease something, then you have to pay something up front, and the payments are due at the beginning of each month. So, you know, we're going to have our uniform series here, but instead of it having it starting on year 1, we're going to start it on year 0, just to kind of emulate that beginning of the month payment kind of thing. Okay. And then this is going to continue for months 1 through 23. But then in month 24, you know, since we'd already paid for that month, the last month already up front, then we're not going to have any cash flows there. Right? Okay. And so I'm going to do something a little bit unique here, which is actually going to be you know, pretty standard for a lot of these kinds of problems. Is that I'm going to make a third column where I'm basically just going to take what we have in the first column, which is buy, and I'm going to subtract what we have in the second column, which is lease. And then we get kind of the, we call this kind of the increment in between. Okay. Because it's basically the difference of our two options like this. Okay. And so if we do that, we're going to get minus 37.5K. Okay. And so, you know, the difference between buying and leasing is that, you know, we're going to pay $37,500 more today. But if we buy, then we don't have any monthly payments for the next 23 months. And so we're going to have a net gain of $2,500 each month. Okay, so that's a positive. And then also at the end, since we're able to sell the machine, we can have, that's kind of like a net gain of $6,000 over the leasing. Okay. Right. And so what we're actually going to do is that we're going to compute the rate of return for each of these. Okay. Okay. Any questions on this? Okay. Okay. So let's set this up kind of the same way that we did the previous problem. Is that we have our two options here. So we have buying and leasing. And so let's compute the present worth of each option and set them equal to each other. And so when we do this, you'll kind of see why I'd had that third column there for buy minus lease. Okay. All right, so let's start with buy. All right, so for buying, we have an initial cost of $40,000. Okay, so that's going to be a minus 40,000. And since that takes place today, you know, we don't need to convert it at all. Okay. And then to this, we're going to add the salvage value. So we're going to add 6,000, and that's going to be P over F. Right, we don't know the interest rate, so we're going to just leave that as I. And then the amount of months that pass is 24. Okay. Right, and then we're going to set this equal to the present worth of the leased option. So for the lease option, we pay $2,500 today. Okay, so that's a present sum already, and so we don't need to convert that. Okay. Okay. And then to that, we're going to subtract the monthly payments. We're going to have 2,500 P over A, right? We don't know the interest rate, right? And this takes place over 23 months because, you know, we don't pay on that last one. Okay, and so just like we did before, we're going to move everything to one side of the equation. So let's move everything over to the left side. Okay, and then what we get from that is we get a minus 37,500, okay, plus 2,500 P over A, I 23, plus 6,000 P over F, I 24. And all this is equal to 0. Okay. And then so from here, what we can do is we can proceed the same way that we did before. Is we look up numbers in our compound interest table. We plug those in for I, and we keep evaluating this until we get a sign change. Okay. But you know, I want you to kind of look at all the cash flows we have in this expression right here. Okay. And then we compare that to our third column here, which is buy minus lease, right? And what you'll see is that the cash flows match up exactly. So we have a large initial cost of $37,500. Okay. Then we had a uniform series of $2,500 each month, and then we had a future sum, our salvage value of $6,000. Okay. And so you know, this is kind of a way that you can kind of not really a shortcut, but it's kind of another way that you kind of see this guy. And kind of going back to, you know, Jonathan's comment earlier, you know, another way that you can kind of view this this expression here is like an investment. Okay. And so remember, for investments, we pay a large amount of money up front, and then we reap the benefits of that large investment over the next few months or years to come. Okay? And so this follows that pattern exactly. So, you know, when we take the difference between them, we have a large payment of $37,500, and then each month after that, we're gonna it's like we're saving $2,500, and then we get a large sum at the end of $6,000 from selling the equipment. Okay, and so now let's start plugging in values from our compound interest table. Oh, before I do that, any questions on this? Okay. Okay, and so let's start plugging in. And so in this problem, I know that the interest rate is between 4 and 5, so let's start at 4. And so we go to the compound interest tables for 4%, and we look up all these values. We get minus 37,500 plus 6,000, and then multiplied by 0.3901. Okay. And then to that, we're going to add 2,500 times 14.857. Okay. And what we get is 1983.10. Okay. Okay. And then we're going to do the same thing for 5%. And then we basically run through all the calculations, and what we get is minus 1916.9. Okay. All right. And so you can see here we get a sign change. And so this is different than the one we've had before. So in the ones before, we've always gone from negative to positive. Here we're going from positive to negative. Okay? And remember, that's because this is an investment. Okay? And so now we know that the interest rate is between 4% and 5%. Okay? So let's go ahead and plug this into our interpolation formula. And so our I low in this case will be 4. And here you have to be careful, right? So, you know, it's tempting to say that you look at these values and you can say that PW low is the minus 1960. But in this case, the present worth that's associated with 4% is actually this guy right here. Okay, so it's going to be 1983.10. Okay. And so we have I high is 5%. Okay. And so we have PW high. It's going to be our minus 1916.90. Okay. And so if we interpolate, then we get IRR is equal to 4 plus 5 minus 4 multiplied by 0 minus 1983.10. Okay. Then we have minus 1916.90 minus 1983.10. Okay. And then what we get is 4.51%. And so in this case, if we choose to buy the equipment, then it's like we're getting a return of 4.51% each month, okay? From just the money that we would save each month, right? All right. Any questions on this? Okay. Okay. And so those are kind of two common, applications for rate of return. Usually they're going to be in situations where, do you want to pay something up front or do you want to purchase something versus an installment plan, okay? And so this is just kind of another way to kind of quantify, how much money that you would save each month, by usually paying up front. Okay? And so let's do kind of one other common thing. So let's actually kind of bring this back to, present worth analysis and annual cash flow. Because remember, for present worth analysis and annual cash flow, what we did was we computed, or we were determining the best option between two alternatives. Okay, and so you can use rate of return to do the same thing. Actually, we've kind of been doing it for the last examples, but we can kind of formalize, some of those methods. Okay, and so this method of comparing two different alternatives is called incremental analysis. And so in incremental analysis, we're going to use rate of return. Okay. We're going to use rate of return to choose the best economic option. Okay, and so in order to perform incremental analysis, so the reason it has that name incremental is that we're going to basically use the same technique that we did in the previous example, where we find the difference in between the two alternatives. And so to do this, we want to find the rate of return of the difference between alternatives. Okay. And so this particular rate of return that we compute off the difference is often called the incremental rate of return. And so that has the symbol, this triangle symbol is called delta. And so we call delta IRR. Okay. And so this is incremental rate of return. Okay. All right. And so to actually, so after we compute the internal rate of return, that's just a number just by itself. And so to actually say if this is a good investment or not, we have to compare this delta IRR to something else. Okay? And then what we're going to compare it to is something called the MARR, which is the minimum attractive rate of return. And so since minimum attractive rate of return is a mouthful, you'll see it shortened to MARR. Right? And so this will almost always be given to you in a problem because this is kind of you kind of think of this as like the market rate, or kind of going back to Jonathan's comment, say you can instead of investing in one of these options, you can just take this money and just invest it in a bank. And so the MARR would be kind of like the interest rate that you would get from the bank. Okay, and so depending on how the delta IRR compares to the MARR, it's going to lead you to do different behaviors for regarding your investment strategies. Okay. Any questions on this? Okay. All right. So let me just kind of give you the two scenarios. So in the case where delta IRR is greater than MARR, or say greater than or equal to, okay. And these situations, remember you're comparing between two different options. And so when the delta IRR is greater than the MARR, what you want to do is you want to choose the higher cost option. And so almost always when we do incremental analysis, our two options here, they're going to have different initial costs. Okay? And so typically the way that you can think of it is you'll have one option that's relatively lower cost, but it's also lower risk and also lower yield in the end. So by investing less and by taking less risk, your possibility of earning more money is limited. Okay? And so the reason we do this is that we want to invest all our money into the higher cost, into the increment, you can think of. Okay. Okay. And so if our delta IRR is less than our MARR, what you want to do is you want to choose the option that has a lower initial cost. Okay. And then so by doing that, you choose the option with a lower initial cost, you're going to have some more money on hand. Okay? And so and then in those situations, what you want to do is that with the extra money that you have on hand, you invest that in the bank or in the market at the MARR. And so remember, whenever we're making an investment, we always want to maximize our gains in the end. Okay. And so if our delta IRR is really, really big, then we gain the most money by just kind of putting all of our eggs in one basket, which is the higher cost option, and letting that kind of reap the rewards for us. Okay. But if the delta IRR is less than MARR, then it's actually more cost effective for us to, first of all, invest in the lower case option. But then whatever money that we have left, we can just put that into a bank and let that collect money with the interest rate given to us, or we can do it in bonds or whatever other options that was set by the MAR. Okay. And so what I'm going to do next is I'm going to do kind of a simple example to kind of illustrate these ideas. Before I do that, are there any questions on this? All right, so let's do a simple example where we're given two options. Okay. And so let's say that this is just a 1 year investment. So we're going to put money in today, and then 1 year later we're going to get some money back. And so in this case, we're just going to have year 0 and year 1. Okay. Right. And so for option 1, let's say that we're going to pay $1,000 today. Okay. And then a year from now, we put it into the bank of magic or whatever, then we're going to get $1,500. Okay. It'd be nice if something like this existed in real life. Okay, so option two, we can put $2,000 into the bank of magic, and then what we get back from that is $2,800. Okay. Okay. And then what we're going to do also, just like we did in the previous example, is we're going to find the difference between them. Okay. And so in this case, we're going to do option 2 minus option 1, right? And so what that's going to give us is a minus 1,000, right? And so that's going to be minus 2,000 minus a minus 1,000, and so the net gain, so the net result for that is minus 1,000. Okay. And then we're also going to do 2,800 minus 1,500, and this is going to give us $1,300. Okay.
I'm sorry, what does the last column say?
It's option 2 minus option 1.
Okay, thank you.
Yeah. Okay. And so, when you're making this this last column right here, you always want to do the higher cost option minus the lower cost. Okay. Because we always want this this column right here to look like an investment. Okay. And so, remember, for investments, we have a relatively large initial cost. And it has to be a cost, it can't be a benefit. So in this case, since option 2 is more expensive, what we can say is that by choosing option 2, we're paying, $1,000 more, okay? And then hopefully if everything is a relatively good investment, then all the cash flows that we have in the future will be positive. And so in this case, we have a positive 13, okay? Okay, and so what we want to do first is let's compute the rates of return for all the different options. Okay? Oh, let me define the MARR. So in this case, the MARR, we'll say, is 10%. Okay. Okay, so first let's compute. First, let's compute the rates of returns for the individual options. All right, so since it's a relatively simple case, we can just use the formulas, okay? And so let's do option 1 first. Okay. So option 1, if we, let's compute the present worth of this. And so we can have 0 is equal to minus 1,000 plus 1,500, okay? And this is P over F, I, and 2, or 1, sorry. And so you can use the compound interest tables for this, but actually you won't be able to compute it because this rate of return is actually ginormous. Or actually, yeah, you can. The compound interest table goes up to 50%, miraculously. And so if you solve for this, you should get a rate of return. So we'll call this I1, 50%. And so you invest $1,000, you get $1,500 back. That's like a 50% gain on your investment, which is ginormous. Okay. Okay. And so if we do the same thing for option 2, okay. And so we compute the net present worth. So we have 0 is equal to minus 2,000 plus 2,800 P over F, I, and 1, okay? And you solve for I, what you get is 40%, okay? So this is I2, right? And so when you compare these two options, you say that, you know, if we invest in option 1, we get a 50% rate of return. And for the second one, we get a rate of return of 40%. It's really tempting to say, you know, option 1 is clearly better because we get a better return or investment. But, you know, what you'll see on next Tuesday is that once you compute the increment, that actually changes the picture a little bit, okay? But we'll pick this up on Tuesday, so we're out of time for today. So thank you everybody for tuning in. I know especially it's the class before the midterm, so, you know, you know, I know a lot of you guys would rather be studying. So thank you guys for coming. And remember, Thursdays are midterm, so we're not going to have, I'm not going to have a lecture, but I will pop in on the Zoom call if you do want to ask questions for that. And the exam will start at 1 p.m. on Thursday, okay? And so, you know, if you're coming on Thursday, then I'll see you then. But if not, then I'll see you guys next week. Best of luck on the midterm. You know, I think you guys are going to do fine, you know, as long as you, you know, can do all the homeworks and do the study guide. You check out the review video. I think, you know, you guys are going to do okay. I took the midterm myself yesterday. It wasn't too bad, okay? And any questions that you have for anything, you know, definitely send me an email, pop into office hours, or send me a direct message on Discord, and I'm happy to answer, okay? So have a great day, everyone. Best of luck studying, and I'll see you whenever I see you. Wasn't too bad, so it was a little bad. Well,
Professor, can
I'll
you go
let you
back to option 1 very quick?
Yeah.
Thank you.
Yep.